going to be factoring polynomials when I have 4 or more terms. How do I go about factoring something that looks like this? The main word that you need to remember when you have 4 or more terms is you're going to use grouping. That's your main word that I need you to remember when you're factoring 4 or more terms. Now, in mathematics, how do we represent something being grouped together? How do we show that in mathematics? Well, we use parentheses. So what I'm going to do is I'm going to group the first 2 of this problem together with parentheses. Oops. And the last 2 with a plus sign in the middle. Okay. Then I'm going to analyze each group and take out the greatest common factor from each group. Okay, so as I look at this first group, do we have a common factor? Yes. Both of these have h to the 2nd power. Okay, h cubed divided by h squared is h to the 1st power. 3h squared, negative 3h squared divided by h squared is negative 3. Plus, this next group, do they have a common factor? No, the only common factor they have is 1. And when I'm factoring 4 or more terms, I do put that 1 on the outside because you're going to need to be able to see what's happening when you take out that factor. Okay, now, I want you to look at this polynomial. Look here now. What type of polynomial do I have? 2 terms is a binomial. 3 terms is a trinomial. And of course, 4 or more terms, that's a polynomial. Well, hopefully you see that I've got 2 terms that are being multiplied, separated by an addition sign. So I've got 1, 2 terms. This is a binomial. Okay, so when I look at that binomial, does that binomial have a common factor? Does this term and this term have anything in common? And yes, they do. Both of them have h minus 3. Okay, so when I factor for the final time, I'm going to take out the greatest common factor from each term. The greatest common factor is h minus 3. Both of them have h minus 3. And if you're factoring 4 terms and you don't end up where you have a common factor like I do, then you've done something incorrect. Okay, then next I'm going to get rid of, by covering it up, the greatest common factor. What's left that my fingers aren't covering up? H squared plus 1. In another video, I'll discuss factoring completely. And some students think that this isn't factored completely because these are perfect squares, but this isn't a difference of perfect squares. So this is the answer to number 1 being factored. We undid the distributive property. Now I want you to watch. I've got h cubed, which is here, plus h, which is here, minus 3h squared, that answer's here, minus 3, and that answer's here. So this and this are equivalent to each other. I undid the distributive property. Okay, let's look at question 2. That one looks strange. It's just a bunch of letters. I'm going to group the first 2 together. Remember, I say always put a plus sign in the middle. This is a minus sign. Still put a plus sign and group that minus with that term. What's the common factor of this first group? Well, they both have x in common. I would have y plus z left. This group has a in common. Look, I'd have y plus z left. And hopefully you notice again that what I have left here is a binomial. I've got one term plus another term separated by a plus sign. And do we have a common factor in that binomial? Yes, we do. We have y plus z and y plus z. So I'm going to factor out the common factor y plus z. And what's left when I cover up the common factor? X plus a. And this is my answer. Now let's multiply to prove it is. Y times x is xy. Y times a is ay. Z times x is xz, and z times a is az. So that is exactly correct. Now I want to look at the next one, number 3. I'm going to group the first two together. And the last two together. I'm going to take out the common factor from the first group. And the first group not only has a numerical common factor of 5, but they also have a common factor of x. So I'm going to have 3. The x's cancel out, m. I'm going to have minus 4, and the x's cancel out. Bring down my plus sign. My common factor, I have a numerical and a variable common factor. 2 is what they have in common, and y. Six my divided by 2y would be 3m. Negative 8y divided by 2y would be minus 4. And then my binomial that I have on this line now, they do have a common factor of m minus 4, 3m minus 4. And I'm going to take out that common factor. And what is left when I take out the common factor? 5x plus 2y. Okay, and I promise it works. Let's look at number 4. Number 4 is a little bit different in that this has a subtraction sign. 1, 2, and 3, all of those were addition signs, but there is a subtraction sign there. Okay, so I'm going to group. I'm going to show you how you handle that. I've got 7b cubed plus b. I'm going to put an addition sign and group that negative with the number, the coefficient that it has there. Okay, what do the first terms have in common? They only have a variable in common, and that happens often. And I'll ask students, what's the greatest common factor here? And they can't tell me because they're looking for a numerical common factor. Well, that doesn't always happen. Sometimes you only have a variable as a common factor. And here b is my common factor. Divide both of these by b. 7b cubed divided by b is 7b squared. B divided by b is 1. And then here, I want to tell you a quick rule that works every time, 100% of the time. If this is negative, you have to take out a negative greatest common factor. So I can make this a minus sign here now. And then what's their common factor? 7. These two actually do have negative 7 in common. Both of these are negative. But this could be a plus, and you'd still take out a negative 7, because if this is negative, you need to take out a negative GCF. Okay, so I'm going to divide both of these by negative 7. Negative 49b squared divided by negative 7 is 7b squared. Negative 7 divided by negative 7 is positive 1. And then My binomial here on this line, it's still a binomial even though there's a subtraction sign. Do I have a common factor? Yes, I do. My common factor is 7b squared plus 1. I always write down the common factor first, but you can have these flipped around. It's okay. I just think it's easier to have that common factor first. And then when I take out the common factor, what's left? b minus 7. That's my answer to number 4. One more to go. It is possible, I don't think any of my examples have it, but it is possible that your 4 terms actually have a greatest common factor. You would want to take that out first because when it asks you to factor, you want to be completely factored. And if you have a greatest common factor, you're not completely factored. Okay, again, look, this one has a minus here. So when I group 9x cubed minus 18x squared plus negative 7x plus 14. Okay, so always group with a plus sign in the middle. And now I'm going to take out the greatest common factor of the first group. There's a numerical common factor and a variable. They both have 9 in common, and they both have x squared. 9x cubed divided by 9x squared is just x. And negative 18x squared divided by 9x squared is minus 2. Next, I have a negative 7, so I know I'm going to have a negative greatest common factor. And these only have a numerical factor of 7. I'm going to divide negative 7x by negative 7. That would be positive x. I'm going to divide 14 by negative 7. That would be negative 2. So my binomial here, do they have a common factor? Yes, they do. X minus 2 is my common factor. So I have x minus 2 times what's left when I take out the common factor, 9x squared minus 7. And that is how you factor 4 or more terms.